Yo, what's up, everybody? Today we are working on our QR code scanner in Zig. Um, we're at this point where, for a relatively simple QR code, we can locate it if it's perfectly axis aligned, and we can like walk the data, and we know like these are the timing codes, these are the like format info. We know that we walk from the bottom right and we do this like zigzag up here, and then we turn left, then we go down here, bum, 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 bum. And when we parse all this out, we do see that we like see the word hello world in this like hello world really shitty QR code, right? And today we want to look at, well, what how do we like adjust this for a QR code that isn't perfect? So right now we're assuming perfectly axis aligned QR codes. So we assume that if we find the center of a finder code, that it's, perfectly a box around that area. We assume that if we walk directly right from that finder, that we're going to hit these timing patterns. We assume that if we walk directly down, we're going to hit these ones. And the real world's not like that, right? So today we want to look through and see how do we get to the point where we can handle something that's not perfectly square, not perfectly axis aligned. And so thoughts are we should generate some form of test, either by going into GIMP and warping it around. I was thinking maybe we go into Blender and we just like slap it onto a plane and just take a photo from in Blender from a different perspective. Then we have to like try running this, see how far we get with our current mechanism on that warped image. Probably not very far. I'm fairly certain that we're going to have to figure out, like, if these guys aren't perfectly square, we're at the very least going to have to figure out their like positions relative to each other and use that to define the axis of the QR code. Then we're going to have to like remove some of these assumptions on perfectly square stuff. So right now our rectangle is just a left, right, top, bottom. We're going to have to like add some rotation to that. Maybe we'll do maybe we'll support like, what's it called when you have like a quadrilateral but it's the two sides are perfectly aligned. We might have to account for some of this going on, right? So we might have to like mark corners instead of rectangle and rotation or something. We'll figure it out. And then we have to adjust our like walking logic so that it follows the axes that we find from the finders. I think it's likely that we won't finish that today, but we'll see how far we go. We'll see how far we get. We will see. Okay, so I think what I want to do is I want to use Blender to generate our test, just because I don't really know what a camera, like what perspective is going to do to the QR code, and instead of trying to figure it out and fake it in GIMP, we can just like create a plane, drop our test onto this plane, and then just take a photo of it, and that solves all the problems for me. So I think in here we go, image, texture, slap this in here, maybe look at it. What are we making today? Gamer QR code scanner, QR code scanner, QR code scanner. And let's get our like little sample QR code. So I think that the sample we've been using is here somewhere. Ooh, why is it not there? Source, libqr res hello world gif. I guess maybe Blender just doesn't take gifs. Do I have ImageMagick installed? Let's do ImageMagick. I think that's how you spell it. Zig012. Yeah, that's what we're on right now. For sure. Then we can do like convert hello world gif to hello world PNG. And then hopefully Blender picks us up. Yeah. And then our QR code's on this guy. Sick. Let's change this to... One of these guys must be interpolation. There we go. Give him a little solid. And then maybe we turn up the brightness of the background and turn off this light. And then we can just kind of... maybe do something like... Let's start not too extreme, right? We could go straight to this case, but there's no point. Let's start with something like, just a little bit off axis. And then we can just screenshot that and save. Cool. So let's look at our, well, first let's copy that somewhere so I don't forget where it is. It's under pictures and whatever today is, this thing. And we'll put this in QR code decoder samples, and we'll call this like May to test PNG. Okay. And then here, we should be able to say, build our application and run it. QR annotator. And we have the input of samples May to test. And output is going to be output. And then we can look and see how the fuck that failed. Overlay SVG. So you're creating like a real-time QR code scanner from real life pics. I don't know if it's like well-defined, really. We're just trying, we're kind of using this as an excuse to like discover what a QR code scanner would do. So I don't know if we're going to take it all the way to like putting it on my phone or something, but it's like, I just want to see, you know, can I discover a QR code from real life pictures, I guess. Yeah, that is, maybe real time is a little strong. But yeah, I do definitely want to do something. Okay, so in this visualization, these red dots are indicating where we think there are potential like finder codes based off of horizontal scan lines. So what we actually are doing here is, if we copy this into here, nope, paste, hello, copy, paste, there we go. So what we're actually doing is we're just kind of like going boom, this way again, this way again, this way again. And anywhere where there's a red dot on this thing means that we found a segment that's like 1 wide here, 1 wide here, 3 wide here, 1 and 1 again. And my gut feel is that this approach should generally work for off angle or like off axis QR codes, because I think I could be wrong here, but I think that through the center of this thing, we should always see a pattern that like almost matches that. Now, clearly I'm wrong, because what's supposed to happen is we're supposed to see blue dots that kind of like mirror the red dots here, but just for vertical scan lines. And for some reason, that's not fucking happening, right? Like here we only found 4. They don't like make it all the way across. Here we found none. And here it also looks like we found none, which is interesting. Because I would think that if we were to take a vertical line through this, we would see it. So maybe we pop open GIMP and do some measurements. Is GIMP the tool for this? Maybe. Maybe it's not. Paste, please. Okay. That's the wrong image. Fuck, when I hit enter here, I think that it's saving by default instead of copying to the clipboard, which is what I actually want. Can we just like measure? Oops. Like if I like do a selection here, that's, does it not tell me? I thought it would. I guess we can just count. So this is at, okay, we'll write here. This is at maybe like, okay, let's draw a straight line down actually so that we have like a ruler to follow. Is there a line tool in this piece of software? Maybe I'll go back. Maybe I will open this in Color Paint. We need shittier software so that I get less confused. Oh, fuck, not this shit again. Oh, glue this down here. Okay, paste. And line tool. And let's just kind of like draw something that we think is approximately straight. Let's make it a little fatter. Okay. And, oh, actually, I think I want it more towards the center. So let's do it like here. Okay. Now, can we say like this on the green line is at 120. So let's just like write that down. 120. This is 190-ish. 190-ish. This is 260-ish. 260. This is 490-ish. This is 570-ish, right? We don't have to be super precise here. And this is 650-ish. Okay, so now the question is do we see the pattern of 1, 1, 3, 1, 1 if we look at these numbers? So it looks like we're seeing a pretty consistent, like, 70 distance here. This is also 70. This is, what we're hoping to see is 70 times 3 should be 210. And we're seeing maybe this is 230. So a little off, but not so far off that it should be a major problem. 490 to 570 is like 80. And this is maybe like 7 to 5 is 80 again. So it's not a perfect 11311, but it's not a crazy off 11311. It could just be that our like level of error is a little too low. I don't really know why it would be different for horizontal and vertical. I guess probably this tilt is probably applying more horizontally, or sorry, more vertically than horizontally. So I wonder if we can do something like can we tilt our camera like left and right ways instead? Let's try that. Let's go to the perspective of the camera and do this like lock camera to viewport. And then I think that we can do something like we come on like straight on. And can I just like rotate this around its y-axis? There we go. Nice. So let's just see if it's like depending on which way we're kind of warping the image. Because it could be that like due to perspective, it's not as perfect as we want it to be. Okay. Can we take off? I guess, how do I make it so that, that's fine. I'll just screenshot this. Fuck it. Blaze it. I guess we want it to be like so far. Is this good enough? I'm worried that like the different resolutions are going to kind of like fuck up the results. But whatever. We can just try it and see what fucking happens. Okay, so did we do anything with that when I screenshot it? I don't actually think we did. We need to save it somewhere. So we'll take this, we'll hit save, and then we will do the same thing where maybe we'll copy this from our pictures. Probably this one, the latest one from May 2nd, and we'll go back to here and we'll stick it in here under samples and we'll paste it and rename it to May 2 test 2. All right. Can we rerun it again? QR code annotator, May 2 test 2. No, fuck. May 2 test 2. I have to press the number 2 before I press enter, not after. It's a hard life out here sometimes, you know? QR annotator, no such file or directory. Oh, because I'm in the wrong folder. Okay. So here, nice. Okay. So that's interesting. So here we're seeing that it's fine. Like the blue and the red are lining up here, which is good. We actually found 2 finders. But now we're seeing that the blue is okay and the red is not. So it must just be that under perspective, oh, this is fucking obviously, right? Obviously things that are closer to you are look bigger than things that are farther away, right? If we can I put this camera back on axis? Fuck off. I know I explicitly wanted off axis, but now that I'm trying to do something else, it's annoying. Let's just get out of camera view. I don't even know where it's fucking looking anymore. Where are we? Here we are. Okay. So like pretty fucking obviously, right? If you do this and we like, is it here where I can change? I can't, this isn't the viewport focal length. Here we go. This one. Right? Like pretty obviously under heavy perspective, things that are close are more pixels than things that are far, right? Clearly this is more vertical space than over here. Here you can't even see it. So it's like pretty clear that that like as we do this, there's going to be some amount of that. And I guess there's a question of is it good enough if we just allow some amount of error, right? Like I don't think it's reasonable to expect this to work. right? If we were writing a QR code scanner that we expected humans to use with their hands and their eyeballs and their phones, right? Like we might support like, you know, some amount of distortion, right? Like we might support this, but like we wouldn't support that. We'd be like, just fucking move your phone, like take a reasonable photo. And so maybe for now we continue on with our existing strategy. Don't try to account for perspective at this stage, and just fucking crank up the error margins, which will result in more false positives, but maybe not to the point where it's like a major problem. Maybe. Okay, I want to go back to the other test. I don't like this one as much. That was just like proof of concept. Okay, so we go back here, and let's just see maybe where, like, look at the numbers for the vertical scan lines and see what's fucking happening. Where's the spec for QR codes? Oh, dude. It's, paywalled. I think it's 18004, 18804, or 18004. I can't remember. 18, not that one. 004? Yeah, here you go. You have to give these guys... why does it... what is this currency? Convert Swiss francs. 216 CHF in USD. $237. 237. That's so much money. For like, what the fuck are you supposed to... I don't really get it. I mean, yeah, it's... That's crazy. I also didn't know, I don't know like why I thought that the Swiss currency would be valued at, but I don't know why I just assumed it would be lower than the US dollar. But good on them, I guess. Okay. So what I've been doing is I've been looking at the QR code on Wikipedia. Right, this page is pretty good, and then I think I found QR code step by step. This is a good resource here. This kind of shows like exactly every single step of like making a QR code, which is like kind of just decoding a QR code in reverse. And then this site here has been super helpful, especially in terms of like error correction. I haven't done any of the error correction stuff on stream, but this kind of shows it in like enough detail that it's good enough. And then if you're really clever, you can Google the ISO code, and then you can type PDF into your Google search, and sometimes you get a result. But don't tell anybody. Don't tell anyone. I didn't look. I promise. I promise I didn't look. Okay. To be honest, even if I had looked at that, it would have been less helpful than the other online resources. So it's not too bad. Not too bad. Okay. Let's say that we have some sort of test QR code, and let's try to adjust our Finder code to work with that. So I think it's in here. So we have Finder candidates in one dimension, and here we are just saying, hey, if these guys are almost the same, so we look at like we run length encode what am I trying to say? Black and white. Like, so we look at this guy and we say like, basically what we did here in Paint. We're just doing this in code where we try to find like 70, 70, 230, 80, and 80. And then we have like an array of those numbers. 70, 70, blah, blah, blah. And then we take the first one and we call this one our reference. And we try to say like, well, if we multiply this reference by 1, is that almost the same as this section? If we multiply by 3, is it almost the same as this section? If it's multiplied by 1 again, is it almost the same as these? So probably we can just like crank this up, right? So this is almost same, has like a hard-coded parameter of 20%. Oh, so we're probably just off. Because the 20% is like, what's... Hello, calculator? Do I not have... Oh, I just typed color paint by default. Calc. What's like... What would this be? So our reference is 70 and our other thing is 80. So you have 80 over 70. What is this minus 1.0? Oh, because we're trying to... What the fuck? What is this minus 1.0 doing here? Was I just fucking high? Yeah, I think I am. This is if I'm within 20%. I don't know what the fuck I was thinking with that 1.0 before. I don't know. I guess like that effectively just doubles the distance in some cases. No, I don't know. That's fucking weird. What a bad... Maybe there's a reason, but I can't see it. Is A always bigger than B or what? Not necessarily. So I guess we should do something like swap them if they're to make them consistent ratio. So we want to do like if AF is greater than BF, swap them. Actually, before we do this, let's just see, let's look at previous me and see how fucking stupid it was. No, I didn't even call it out. Sometimes I write commits and I'm like, I was fucking stupid, don't trust me. If I'm in like rapid prototype mode. But I didn't do it that time. What am I looking for? I was trying to do our QR decoder thing, and it was here. I was fixing it. Is almost the same. So we're gonna say if A is greater than B. Do we swap them? I don't think swapping them is right. So if we're trying to say, hey, A is 7. And B could be anything from the range of like 5 to 9 or something, right? Let's just say that's the case. I think that if we we have 5 over 7 is going to be, we want to do like 7 minus 5 over 7 gives us 2 out of 7, which is like some threshold. And then we want to do 9 minus 7 over 7. Yes. And is this the same as swapping and then dividing? I think not, because 7 over 9 is not the same as 2 or 2 out of 9 is different than 2 out of 7. Yeah, I think that's right. So what we want to do is we want to say A minus B. We want to absolute value that. And then divide that by A. That's the ratio of like our distance from the value. And then we say, is this less than 20%? That seems more reasonable to me. But I'm sure that whatever I did before seemed more reasonable to be that day. But let's see if this at least changes the behavior. We might need to increase the threshold, but at the very least, maybe calculating threshold right. By my definition of right, which is I think it's right today. Okay, so we found one. We still have a lot more like density in red than blue. So maybe we do just say, what if we try like 30%? Right? What if? You know, let's just get crazy. Let's get wild out here. There we go. Okay. 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 That's not bad at all. So now we have like pretty dense red and blue lines, which is nice. We have this like green dot in the center, which kind of indicates we found a finder. And then you can see pretty clearly what we're doing here is fucking stupid. So we have our 3 finders, and then we go like, well, the top Y value must be the top of the QR code. And the most left value must be the left side, and the most right side value must be the right side. That's just like fucking wrong. And then we try to like walk these timing codes, and then we go like, what the fuck? That's not what I expect to see. And then panic. So I think, let's see. I think what I want to do here is I want to draw like, hold on. We can get smart here. I want to copy, paste. I essentially want to draw, what color isn't used here? I want to draw this triangle. And the idea is if we draw this triangle, we should be able to figure out like this vector and this vector. And if we find that, then we should be able to, at the very least, draw a box that's like aligned like this. I don't know if the size will be right from that information. I'm not 100% sure on that. We might have to do another walk to figure out the width now that we know the orientation. We will see. We will see. But let's see. What if we were to figure out this triangle? What do we do here? I guess we have. We want to calculate the angles between each one, and the biggest angle is the top left. Is that always true? Actually, you know what we can do? We can actually get crazy here. Well, let's get crazy. Let's in 3D just kind of slap some. How do I? Oh god! Oh god! Oh god! Bring me my lines back. And do it with this. And can I? Oh god! What have I done? This one. Okay. Let's go over here, and let's do this. Yeah, yeah. This is scientific, guys. Mathematical and scientific and precise. We are all of those things all the time, and don't let anyone tell us otherwise. Okay. Let's just kind of slap these guys here. And I just want to see if I believe that the biggest angle is always in the top left. Let's also print these a little bit above so you don't see like weird flickering. Do I believe that? It's also hard because my stupid fucking 3D brain is like trying to do like the projection in my head, which is not what I want. How do I make it so this is clear to see? Right, like here, I could maybe see an argument that is this angle bigger than this one? I'm honestly not sure. In this 2D projection, that triangle looks kind of like this. And definitely this angle is the biggest in that world. But maybe if we are like aligned enough, maybe? Like, that's clearly the biggest. Oh, but that's also not the triangle that we drew here. This is like this, maybe even a little flatter. And then like this. Kind of like... You know what? We'll just try it. Let's just assume that this is true. I'm not positive that it's true. Well, wait a second. We don't even have to go by angle, right? We can just go by which one's missing. Is that true? Right? Like, there's clearly, like, if we were to try to draw a box, there's clearly a square missing over here. Is there some way to deduce that all the time? Let's think. It's hard because in my head, I'm, like, looking at these being like, I know where they are. And it's, like, not the case for the computer. Is it true that the longest line is always this one? I think it should be true. Here, that's pretty clearly longest. I guess if you were like really warped, it might not be. Okay. Let's assume for now that both of these things are true. That this is the biggest angle and this is the longest one. Can you find the missing one by identifying the disrupted border? What do you mean by disrupted border? Like, kind of look for, like, you could try to fit a square to this thing for sure. It looks like a rectangular rectangular triangle, so the hypotenuse is always the biggest. I believe that the hypotenuse is always the biggest without perspective. What the reason I was just like kind of going like this is because I'm not 100% convinced that it's always the biggest once you bring perspective into account. But I think probably with the amount of perspective that we're willing to support, I think it is. So let's do that. We'll just say that we'll look for the longest of these 3 lines and then ignore that one. And then from there, we should be able to figure out the axes. Okay. Let's just at least start by maybe drawing those 3 lines on the screen. Let's start there. And I guess you could argue that at this point we are, in fact, looking at trying to figure out the QR orientation for the finders. And maybe we should even say, hey, we did this at some point before this time because when I go back and make YouTube VOD, the chapters will want to start earlier. Or you can use Al-Kashi theorem, I guess. We're getting crazy out here with the math. What does that mean? I've never heard of this. Law of cosines. Relates to lengths of sides of triangle, cosine of angles, blah, blah, blah. The fuck? So, what does this mean? Cosine formula or cosine rule. Law of cosines. Oh, sure. Adjacent over hypotenuse is like related to the length. Yeah, sure, whatever. Can't you apply a perspective adjustment matrix? But I don't know, we don't know what the perspective is yet. We're trying to discover the perspective by looking at the finders. And maybe that's the wrong approach. You could probably also do some form of like, once you have the finders, you could approximate the corners and maybe try to find like these lines. That's probably possible. But that sounds harder than just picking the longest axis. I think for now, I'm just going to pick the longest axis, and we'll, in the future, discover that that's not good enough. But for now, it's probably fine. Okay, so where the fuck is our QR code? Here we go. And, well, let's look at our visualizer code, actually. So we have QR annotator visual main, probably is where this lives. And in this guy, we try to visualize. And so here, visualize finder state. That's probably what we're looking at. I see. And this guy iterates, runs this like algorithm, and he extracts the horizontal candidates, the combined candidates, blah, blah, blah. And I guess at this point, he probably knows the 3, like which 3 things we consider finders. And so here we can just draw the lines between them. Yeah, so we can, I guess, is there any point in drawing these? Well, let's just double check. Like, if we draw the lines, then we know we have them. Might as well. Do we have a draw line function on this guy? Draw box, draw line, draw box, draw text, draw circle. I guess let's add a draw line. And in an SVG, that's something like, we're going to have x1, x2, or maybe we'll say x1, y1 goes to x2, y2. And this is going to be a line, and I don't know what the SVG line is, but it's probably just x1, x2, y1, y2. Probably, yeah. Okay, so we'll call this stroke parameter here. And here we'll just start throwing parameters at it. x1 is x1. Shocking. Shocking, shocking, shocking. Boom, 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 boom. And then we say we are finished this node, and we have to set the stroke value to stroke. Boom, boom, stroke. Stroke to stroke. Okay. Now, when we are doing our visualization, we can draw a line between each pair of ROIs, which is something like we have 1, 2, and 3, and we want to go like 1 to 2, 1 to 3, 2 to 3. Yeah, so we do like, it's double nested 4, I guess. 4 ROIs. This. And then we do from for I to ROIs len is j. And we draw a line between them. So we say A is ROIs I and const B is a ROIs j. Instead of trying to draw a triangle in the existing finders, can you just deduce the missing finder by drawing a square on the first 3, finding the missing one by detecting discrepancy between the square and the borders, and searching outward for the perfect perspective? Unsure if that's easier. Let's see. What are you saying? You're saying deduce the missing finder by drawing a square around the first 3. So this is the square we're drawing around the first 3 right now. Then detecting the discrepancy between the square and the borders. So you could maybe say that we should rotate this until like the edges of this guy line up with the edges of this, which I think would require some sort of like using finder edges to continue the squares. Yeah, but I think that would require some sort of like intentional alignment that we don't have yet. I guess you could maybe argue that these red dots and these blue dots form like a guess at your axis. You could definitely argue that. But I don't think that's easier. I don't think. We'll see though. Well, I guess we won't see, but we'll see if what I'm saying is hard. So we're drawing from like a... What are these like... ROIs is unknown? For real? Oh, my language server is using the wrong version. Hold on. Export path is path to this. And then I think that hopefully my my resolution of types is a little better now. Does he know? Ah, yes, now he does know. Thank God. Because without autocomplete, I'm lost. So what is this thing? This guy comes from rect. So we have top, bottom, left, right. But I think it's CX. Yeah, let's go from center. So we have A center. And then what parameters do we have? X1, Y1. So we have A center Y, B center X, B center Y. And then we'll just make it like, I don't know, orange or something. Doesn't fucking matter. Hello, Mr. Zigzagger. Hello. Hello. Okay. Do I get lines? No. He doesn't like... cannot add node while in attribute state. What have I done wrong here? Do I not... Oh, I didn't... I see. I forgot to finish the node. That's very important in our XML. We need to close the tag, or else it gets angry. Okay. Cool. So there's our triangle. Sick. Missing finish node and draw line. Wow, you caught it. Nice. Nice, nice, nice. Okay. So, can we maybe write down their lengths as well? Maybe we'll color... We'll try to find the longest one. So we'll do something like... const longest line. QR code should be able to handle slanted angle cases like this. I mean, I think that like at the very least, it will never be perfect, and so I'm trying to use this as an extreme, maybe one of the more extreme versions of something that we should be doing anyways, which is correcting for alignment at least a little bit. I've noticed that pointing my phone at stuff like this seems to work okay. So this is more like I don't really know what is expected to happen, but I know what I want to happen. I want this to work. It's not like this QR code scanner is ever going to be used or matter, but it's like, this is a problem I'm interested in solving, I guess. Okay, so this guy's going to be something like that has like an X and Y position. Do we have like a point thing anywhere? Should we add one? Maybe. We'll just say, what is a line? He has x1, which is going to be a float, and y1, and x2 and y2. And I guess he'll be... How do I, like, can I do this in this language? Is that crazy? Wow, that actually works? That's crazy! It will be used. QR code scanner and Zig is very useful, I mentioned. I mean, surely it's not more useful than just writing, like, using libqr code, whatever. Like, whatever, like, the default lib is. Like, surely it's not... And I'm not really ever planning on making this, like, good. So, if somebody used it, I would tell them not to be honest. Okay. So we have, like, longest line length is going to be a u size starting at 0. And we'll just do a little Pythagoras. So we'll say const this line len is equal to b cx minus a cx. Here we'll say const x dist is this. Boom boom. And the y dist is the same but for y. And then this line length is x dist times x dist plus y dist times y dist. And then we say if this line len is greater than longest line len. Longest line len is equal to this line len. And longest line is equal to x1 is equal to a dot cx, x2b, yy, ab, yy. Okay. So expected type F32 found u size, because this guy should be F32 here. And then we should just be able to draw just the longest line. Let's do that. Let's do that. So here our longest line is going to be longest line x1, longest line y1, longest line x2, longest line y2, and orange. Okay, how's that look? I can't imagine that this is wrong. Why is it drawing 2 lines? Oh, because it's in a for loop. Oops. I mean, I can't imagine it's wrong. Immediately it's wrong. Okay, cool. So we have that, which means that we should be able to derive our axes from the other two. And the question is how? I guess, oh, okay, let's look at this. Let's turn this guy 90 degrees. 90 degrees again. Right? We need to somehow determine that this guy is top left. So how do we do that? We know that these two guys are not top left. So we just have to look at the other one. So we can say that, like, var TL finder is going to be a u size. And he'll start as undefined, I guess. And we'll say TL finder is the other one. Which is... So we have, like, what, 0, 1, and 2? And we've taken 2 of these. Is there, like, an easy way to pull out which one the third one is? Like, I feel like there might be some clever math to do here. But maybe instead we just loop it. So you say for ijk, yep. I guess we'll do to rois.len. We just say if ROI's len, or sorry, if k is not equal to I and k is not equal to j, we say TL finder is equal to k. And I guess we can, there's always clever math to do. It feels like something that where it's like you could do some sort of like addition and modulo, or maybe even throw some like XORs in there or something, and like there's an answer. I'm just too lazy to figure it out. Okay, so now we should be able to say, can we draw, let's only draw the box right now for the top left finder. And that should draw a box around, oops, that's Blender. Here we go. Perfect. Cool. And now how do we decide which way is which? We need to like pull out our y-axis and x-axis. And I don't really have an obvious answer in my head of which one is which. Like we know up is always where down isn't. You know what? You've got me there. Like, what else could I possibly want? So there's something about like, so we have the long line and we have the top left. And I guess if we got our axes wrong, that's like a flip over like the diagonal, I think. Right? Like if you were to draw, where's paint here? If we were to draw this line, getting our x and y axis flipped is like flipping over that line. There's something about like figuring out clockwise and anti-clockwise. Maybe that's helpful in some way, right? Like we know that going clockwise should give us the x-axis. The missile knows where it is at all times. This is because it knows where it isn't. By subtracting where it isn't, where it is from where it isn't, or where it isn't from where it is, it obtains a difference or deviation. Thank you for that. You guys are on point today. Okay, so in this scenario, you can't even just go by like world Y and world X are useless. When I'm rotating this, I'm thinking like, well, here I know that this is supposed to be X and this is supposed to be Y. So what the fuck am I supposed to do? What am I supposed to do? Yeah, you do just need, there's something about like rotational coordinates where you know where this line is. Okay, let's get crazy. We know this line and we know this line. Does that help us at all? Surely just rotating clockwise here and counterclockwise here. You want to go negative 90 degrees points towards this guy and positive 90 degrees points towards this guy. And is that what I'm supposed to be doing here? Supposed to be as strong. It feels like that's like the first thing that's jumping in my head. But I'm not sure it's right. You know? Well, I guess I know it's right, but I don't know if there's like some like if I'm doing something really really obvious, if there's like an obvious simpler solution than that. But like the fact that this is missing also feels like it's some form of like obvious indicator. I guess not. This diagonal doesn't mean anything. This one does, though. So say we start with this line. And we go relative to this line. Where is this? Which direction is this? Okay, yeah, that helps me. For sure. Because if I know which direction this is, from there, it's just, well, let's double check that. So I have this line and I have this line. X is clockwise from that line, Y is counterclockwise from that line. Okay. I feel like that's what I want in some way. So we take this line, he's got some orientation. Oh wait, what about if I like look at this? Both of these guys also have some direction, right? We take the top left corner and we subtract it from each of these. Does that help us at all? No, maybe. Yeah, okay. I'm pretty sure it's this. I am pretty sure this line is what's important. So we can say, how do we get that line? Is that even a line that we can get? We'd need to look at like the center point of this line and then subtract the center of the ROI. And then we get this direction. And then from that we can deduce X and Y, I think. Maybe. I don't know. I don't fucking know, man. Let's just draw that line and see what happens, okay? We'll just see what happens. So we'll look at the other lines. Dude, I feel so fucking stupid. I feel so fucking stupid. Okay. So we look at our longest line. Is the goal to correct the perspective and then read the data, or can you just read the data without correcting perspective? I think you can just read the data without correcting perspective. Because I think that, like, if you were to, like, you don't need to, like, how do I say this? By turning this thing into a square, you don't gain information, right? The information you have is the pixels that are on the screen. So any amount of, like, warping actually might lose you info. So I think what I'm planning on doing is, like, creating an iterator that, like, starts here and walks this way type shit. But while we just have to find the axes to walk, then we get something. Okay, so let's just do, we'll take the X, we'll try to find the center of the long line. That feels like it means something. So we'll take longest line X1 plus longest line X2, and we'll divide this by 2. And then we say const mid X is equal to this. Mid Y is the same, but for Y. And then we'll draw the line from mid X, mid Y to the center of the other guy. So that's like something like ROI's top left finder dot center X and ROI's TL finder dot center Y. Let's just see if that gives us something that looks kind of reasonable. That's not Firefox. Okay. Okay. So that's a line. That's a line. It means something. And then from here, we just go whichever point is clockwise from here. Which is like this vector projected onto this line here gives us something. Is that true? To figure out which one is clockwise. I mean, the stupidest thing, I'm slowing down in my head because, like, obviously, if you just, like, the world's stupidest brain in my head is going, hey, what if we just like looked here and then looked here and then looked here and then looked here, and eventually we'll line up with this way and we'll know that one's on the right. But surely there's like some better math to do that, right? Like surely that involves some sort of dot product, probably some sort of projection. Yeah, so given okay, I want to look at this case because this guy is the worst case in my head where you just swap the axes. We have some triangle. Boom. I guess we'll draw this first. We have this. Boom. And we also have, oh my god, bring me my colors back. We also have this, and we'll draw the arrows as well because I think that's helpful. So we have this vector, and we don't really have like an ordering between these 2 points. We don't have an arrow there. We just have like a line. But we do have this. We do have this vector here. We know which direction this is pointing. And in this case, let's just say you were to project this line, this like pink line here, onto this orange line here. You would have something that ends up... I think that the difference between these is like positive and negative. Right? I think if I dot product onto... Hold on. Let's look up dot product. That'll help my brain. Dot product. Let me see a picture. Give me a picture. Here we go. So we get positive. Okay, hold on. Give me something with colors. Here we go. So triangle with vector edges A and B separated by angle theta. No, I want the picture. Give me a picture. A cos theta. Right, so given two vectors, your projection should be 0 if they're 90 degrees from each other, and positive if they point in the same direction, and negative if they point in different directions. According to this axis. So both of these guys are actually going to project negative in this case. Like, if we were to say that, like, this way is positive, then both of these guys' projection onto him is pointing backwards. So the dot product there isn't helping us. Dude, I feel so fucking stupid. Does the angle... Does getting this angle help us? It must. Surely this angle is positive in one scenario and negative in another, right? If we consider... Oh, wait, hold on. I'm an idiot. Wait, hold on. We need to, like, you take this line and you put it here. Like, you take this guy and you shift it over. If you imagine your two vectors starting at 0, so you have this vector and this vector. And then you have this angle. No. Yeah, this angle and this angle. And surely they're opposites of each other. Surely they're one of them is going to be negative and one of them is going to be positive. Let's just calculate the two angles and see what we get. And then maybe it'll tell us something of value. Okay. So we have some ROI index. And we can say, this was me during my dynamics exam. Yeah, where you're just like, I don't fucking know. You just like say stuff and then like, well, we'll try that and maybe that's useful. Linear algebra is fake math made up by the global elite to trick us. Man, linear algebra is so sick though. It's so cool. Like, the tricks that you get out of those like matrix multiplications are so. Also, I've never really understood what the fuck is linear algebra. This is, oh man, this is gonna make me sound so fucking dumb. But like, is linear algebra just like matrix multiplication? Like, whenever people like I've talked to people and they're like, "Is your linear algebra any good?" I'm like, "No, I don't even know what the fuck it is." And then we start talking about stuff, and they're like, "What we were just talking about was linear algebra." And I go like, "Oh, okay, if you say so." Like, I don't know what the fuck we're talking about. Just like numbers, multiply vectors, matrices, man, is like the level that my brain's working at. And I shouldn't say that because if I ever interview for like, sorry, when eventually I interview for a job again, and I'm like, if you want to know what it's like to work with me, go check out my YouTube VODs. They're gonna hear me say vector dot product matrix multiplication algebra, man, and they're gonna go like, oh my god, we'll never fucking hire this guy in our fucking lives. Okay, so if ROI IDX is equal to top left finder. Continue. Yeah, matrix linear transformation, so linear algebra is basically just matrices and vectors. That's how I feel. Okay. So we say, hey, we have I guess we want to say x. What we're looking for is the x direction, or we'll say x direction index. One of these finders is going to be considered positive x. That seems reasonable. And this is undefined. And we'll also have another one for y. Yeah. And all we're going to do is we are going to calculate the angle between these things. So let's just do our little high school trig. So we're looking for this, which is cosine theta is equal to A over B. So we do inverse cosine cos theta equals A over B. No. B over A. Okay. And then if we want to get from there to angle now, you do A cos B over A, maybe? Zig standard library. Cosine. And then there's, okay, I don't know the difference between cos. I know that my calculator growing up had like an H next to the cos and an A next to the cos. I'm pretty sure A cos is the one I want. We can check this very easily by doing, we can just check that, we can check a value that we expect. So if we draw our like 1, 1, root 2 triangle, and we're looking for this. So if we do, this is like 45 degrees. So if we do A cos 2 over 1, can we make this less shit by scaling it up? Okay, what if we do a different triangle so I don't have to calculate root 2? I think it's 1, 2, 3 is 60 degrees. Oh wait, I don't have to worry about root 2. We'll just do 1, 1, root 2. So we'll say 2. What is this calculator? Settings, science mode, statistics mode. Where's my like arc cos button? Do I press shift? Shift. Ah. I mean, the fact that this just says ACOS is a pretty good indicator. I'm pretty sure it's going to be ACOS. Dude, I feel so fucking stupid. This is crazy. Okay, so if I do like 1 divided by, where's divided by on this thing? Divided by square root of 2. Is there a square root button on this thing? Is there no square root? Bro. Oh, here. Square rooted. Okay. And then I arc cos that, not a number. Oh my god. 1 over root 2. So we have 2 square rooted. And then we invert it, and then we acos that. There we go. Okay, I just wanted the confirmation there. So if we stood math acos the hold on. These guys aren't axis aligned. Is that okay? That is fine, because we're assuming we're assuming that this is 90 degrees. Which is a good enough assumption for us. Yeah. Yes, I think it is. So we say, hey, whatever this line was, mid x to the ROIs. So we're going to say comparison line is length is mid x minus ROI's TL finder CX. Fuck me. Stood math square. How? This to the power of 2, which is a fucking stupid way of doing this, but shut up. So this is the x distance. This is the y distance. So we add these and we square root them. Okay. And then we do yeah. Hold on. Don't we lose direction if we do just lengths? Don't we lose? I guess we know that their directions line up? Dude, I feel so fucking stupid, man. Yeah, hold on. If we just do cosine here, we are going to take, like, we're just taking, like, this line length and this line length and ignoring the signs, which feels very important. Right? Like, and if you have, like, a obtuse triangle, you can't cosine this, right? You need, because there's no right angle anywhere, which is kind of the state that we're in here. Let's go back to thinking about dot product. Both of these guys project dot producting gives us the same thing. Right? They both project backwards. Dude, come on, man. Okay, what if we draw it a different way? Hear me out. We just draw it like this. Dude, whoever at the start of stream said that this stream was GigaBrain is eating their words right now. Okay. So we have this line, we have this line, we have this line. What do we know about these things? What if we draw them all here? Does that tell us anything at all? Is it just... Is it just we know that this is 90 degrees? Have we spent all of this time just looking for this 90-degree angle? Certainly that's what's just happened, right? Yeah. Someone's just like, I guess. Dude. Fuck, dude. This is what happens when you're just, like, deep in the sauce and you just, like, don't pick your head up. It's like, you know, I got like so into, like, this line that I forgot about these ones. This is just 90 degrees. Okay. And if I get this backwards, okay, so we have this triangle. Now let's look at that triangle from different perspectives. So if we have this triangle, this one, and then whatever the other one is, this one. Now, in this scenario, we just have to we always, well, let's log x and y axes. Let's look. So in this case, this is the corner of this guy is always the top left. So in this case, it's x, y. In this case, it is, I guess we can even like log the directions here. So in this case, it's x goes this way, y goes this way. Yep. And I guess in this case, it's, we need more space here. We need more space. We need more space. In this case, it's x here and y here. And in this case, it is, this is the happy path here. Love the descent into madness kinds of vibes in the stream. Dude, I'm going fucking crazy. I'm gonna lose it. If you want the fourth point, do as you said, just take the line between the corner and the middle of the hypothesis and double it. Yeah, I'm not worried about that corner right now. I get that. What I'm worried about is, how do I say this? If I have, say, if I'm just given these 3 points and I have to determine which way is x and which way is y, if I say that this way is supposed to be x, if I accidentally decide that this way is x and this way is y, the whole QR code is inverted. Like it's like flipped. It's like I flipped it over the diagonal. It's like if I did, I don't know if I don't have a quick way to draw it. But it is like it gets flipped if I do that. So I'm just trying to make sure that I get these directions right, and I'm just not 100% on this. So given these two lines, if I project okay, I'm pretty sure it's like if I project A onto B, no, both of these projections give me positive? No. To get from A to B, it's clearly 90 degrees forward, and B to A is clearly 90 degrees backwards. So I feel like there's just some obvious check to do there. I think you can cross product to, oh, fuck. Of course, man. Thank you for saying that. Cross product gives me the third axis. There we go. Okay, fuck. Obviously. God damn it. Yeah, you're right. Okay. So, yeah, this is exactly what I want. Thank you. Jesus Christ. My poor little brain. So we have, how do we calculate this thing? A cross, yeah. Oh, look at this. This is exactly what I want, right? We have, if it's theta is, one of them is positive, one of them is negative. Great. What is the definition? A cross B is the magnitude of A and the magnitude of B sine theta equals n. But there's like another calculation where I don't need the angle yet. I just have like the vectors. Geometric meaning. Blah, blah, blah. Algebraic properties. What's the second formula? A cross product calculation vectors. Is there not a second? I thought there was a, wait, matrix notation in this page. Matrix notation. Oh, yeah. Here we go. Can also be expressed as the formal determinant. Right, so I'm in 2D, so I don't have I, J, and K, I just have I and J. So it's just, I think it's just like, so with what is A and B here? What are my vectors in this scenario? A and B are my vectors, so I have A across here, B across here, K equals 0. And so then I just do like this times this, right? It's just, right? It's just, hello, delete, go back to somewhere I can work with, paste. What the hell? Right? Is essentially just, god damn it, get me where I want to go. Like, I'm just doing this plus that or something. Or this minus that. Yeah, okay. Okay. Yep. Got it. Okay, so let's just see. So we have A1 times B2, so that's just going to be function cross given x1, y1, and x2, y2. This is just x1 times y2 minus x2 times y1. Is that right? 3, anything in this, the 3 is 0. So 0, 0. Ugh. 2D cross product. It's so simple. I know it's so simple, but I need it to be fed to me like a stupid little child. Oh my god, it's so much numbers. Just tell me here. Perfect. This is what I want. Yeah. X times Y minus Y times... Yep. Cool. Yep. Okay. Okay. So you're writing based on first principles thinking, not implementing an algorithm. I don't know what the fuck I'm doing. Let's be honest. Who knows what the fuck is going on in here? Okay, so we need to find, let's start by finding the 2 lines. So we have var, okay, let's just start by making a line thing. That will help us. So we'll say a const line is equal to some struct, which is just this. Then longest line is of type line. And now we have a line type that we can use. And here we can say var A is a line that's undefined, and B is also a line that's undefined. Okay. Maybe actually what we want is more like a var lines is 2 lines. Perfect. Okay. So now we iterate over our points, and we know which one's the top left one. So we skip, if we get the top left one, we say fuck you, and we'll say lines idx equals 0. Right. Defer lines idx plus equals 1. And so we're just going to push into both of this array. And for both of these guys, we're going to start at the top left finder and work towards the other guy. So we're going to say, so var delta x is equal to something. Dude, my poor fucking brain. ROI is at the ROI IDX center X minus ROIs at the top left finder center X delta Y is this. Same thing, but for Y. Cool. Then I guess we actually don't need, we only need to store the end because we're assuming that the 2 points starting at, the 2 lines are starting at 0, 0. So we actually only need like const point. And we just say X F32, Y F32. Yeah. So this is going to be 2 points. I guess technically vectors, but whatever, I don't give a fuck. And we say lines, line IDX is equal to X equals delta X and dot Y equals delta Y. And then at the end of this, we should, let's just draw those 2 lines. No, we can't, drawing them is not trivial. It's fine. It's fine. So let's now cross product those. So lines 0, X, lines 0, Y, lines 1, X, and lines 1, Y. Jesus Christ. Okay, const val is equal to this, and we'll just print it. Val is a number. Of course, I need to write these as const, not bars. Of course. And then, value of type is ignored at 181, right, because I just fucking wrote that for some reason. Okay. Val is negative number. I guess let's do, we want to cross product in opposite directions. And what we should see is that we get the same value, just inverted. Okay. Right, of course. That's how the math works. Okay. Now, the question is, I think positive is clockwise. I mean, we can just look at whatever, where was that picture on cross product? AXB is positive. BXA is negative. Okay, so we're looking for the positive one is our Y direction, I think. I guess we'll just find out. Counterclockwise is positive, I think. Yeah, okay, cool. That lines up. So we'll just say if this is greater than 0, lines const x line is equal to undefined. This is going to be var x line is going to be a point, I guess. So calling it line is kind of silly, but whatever. We'll call it's actually x point ID. And I guess I actually want to store, in order to draw the lines effectively. What do I want here? What do I want? I want to eventually get back onto our visualization, and I want to see a line colored according to the axis. So I want to see red going to the right and blue going down or something. And I think the easiest way for me to do that is to store like this, a point as well as the IDX. I don't know, man. When we're in this mode, it's like everything is fucking stupid and nothing makes sense, but and all of the code is shit, but hopefully we end up with a result at some point. That's kind of the level that we're working at right now. Just do something and clean it up later. Okay. So in this case, we have the const x idx x point index. The finder point that is along the x-axis. Yeah, that's a word that we could use. This is going to be undefined at this point. And we also have y. And all we have to do is if this is positive, we assign one, and if it's negative, we assign the other. So if it's positive, the x point index is lines 0 idx, I think. I guess we can just always swap it if we get it wrong. yx, cool. And then here we'll draw a line from ROIs. We'll go from the top left finder to x point idx cx and ROIs x point idx.cy. We'll draw this one in red, and we'll draw the other one in blue. And please God, let it be okay. Fuck. No field name X in this bullshit. Right, because this needs to be point dot on all of these, because we rejigged our struct. And cannot assign constants. This is var and var. Cross will only give you 2 states, plus or minus, but I think you're trying to differentiate between 4 states. I don't think I am. I think that I'm guaranteed to be at 90 degrees-ish here. So I'm not really worried about like the other 2, I think. I could be wrong, but I think. At the very least, this is right. We have red on this line and blue on this line, which is exactly what I wanted to see, right? We said X is red. Okay, and now let's just do, like, can we just get a little wild with it and just kind of try a few? So we'll do this one, and we'll save it. I'll just, whatever. Let's just do a couple. Save. Oops. Save. Okay, let's just try all of those. Okay. So we have pictures, and we have 2024 0502 52732.png. We refresh. Fuck me. Fuck my life. Fuck everything. Okay, so maybe it was too rotated for it to work. God fucking damn it. God damn it. God fucking damn it. My life is so hard sometimes. Let's just go back some more. Let's just try some of, like, see if any of them don't crash. That one fucking crashed too. Super cool. Also crashes. Super cool. They're all crashing because they're all just not finding the finders anymore. So, fine. Let's go back. Let's just do a simple case, maybe. This thing. Let's try this. That seems pretty fucking straightforward, right? If it can't get the... Oh, it's because my fucking background color, I changed it. I'm an idiot. Let's try that. And can we put it back to black and white? I bet you that's related. We'll find out, though. What is the latest? 857. Shift amount is greater than the size of the type. Interesting. That's a new one. This is at QR. Yeah, that's new. I haven't seen that one before. But we can maybe get out of this by just returning early. And then that problem won't happen. If true, return. Oh, interesting. That is still happening. Where? The fuck? Where is that happening? QR zig come from main 328. I've already visualized. So why is my thing corrupted? If true, return. Is it that the file's not flushing or something in the crash case? Oh, there we go. What the fuck is going on? Refresh, refresh. Is it just like actually corrupted? What's going on? Yeah, we just never flushed the image, I guess. Defer, visualizer, finish, visualize finder state. I'm so confused. Zig, build, and run it. What if I run it on... Oh, it's because I'm not fucking running it output to output. I'm just an idiot. I have to output the output, you know? You know? There we go. Hell yeah, baby. Okay, so that one's working. We have red line on this axis, blue line on that axis. And we have to keep remembering that blue line is supposed to be on the, like, QRY. Okay, and let's just try a couple more. So in this case, if we do this one, this should be 53117. Oops, I wrote .png twice. Hard life. Refresh. Oh my god, we fucking got there. It was really embarrassing because it was just a fucking cross product, but you know, sometimes you haven't done any linear, like any 3D math for 6 months and you just forget. And it's embarrassing, but you'll live. Yeah, that's looking pretty good. Red's always on the right axis. Pretty fucking good. Yeah, that's sick. That's sweet. So now I guess the right thing to do is align these finder segments. Like, let's try to get this region of interest rotated to, like, kind of fit this box okay. I think that's going to be a nice next step. So we can probably do something like... let me think. So in our types, sometimes you think things should be in your long-term memory, but it seems to only stick in your working memory. I mean, it's so stupid too, because I was so fucking close. I was thinking about dot products and projection. I just forgot to think about. It's just so stupid. But yeah, I guess it is just like when I was working with 3D more often, it was just in working memory and just disappeared, I guess. Okay, let's just start by adding like a rotation field here. And we'll set it to 0 everywhere. And then that should make all of the code that is using this guy right now just continue working the way it is. I guess we don't even need a function. We can just look at it. And I guess even for now, if we're just going to try to draw the boxes, we can start by just getting the rotation. We can just calculate the rotation here before drawing the boxes. So we have some line, right? We have the x direction, which we kind of lost actually. Maybe we'll kind of store this here. Var x dir is equal to which is going to be a point is undefined. And here we'll just say x dir is equal to lines 0 dot point, and here x dir is lines 1 point. Great. And I guess our rotation of the box. First of all, can SVGs even render rotated boxes? Let's check that first. SVG rotated box. Actually, what am I doing for my draw box? Am I just drawing 4 lines? No, I'm drawing a rect. Okay. SVG rect. So this looks pretty axis aligned, but I think that there's like a SVG rotation transform that you can add that's like just, hey, could you fucking rotate me by 45? Yeah, here we go. So here it's rotate 3 numbers. What are those 3 numbers? A is angle and X and Y are center. So I probably just don't have to worry about center of the box. And so I just need to set the angle, and this is going to be rotation about 8 degrees. Is this clockwise or counterclockwise? Here he's rotating by... I can't tell. I guess it'll be really obvious though. So maybe here we'll just draw box rotated. And we'll just do the same thing where yeah, fuck it. I don't really care. It's fine. We'll copy paste for now and we'll deal with the fallout later. We don't need a fill for this specific case. I'm just not going to worry about it. And we're going to say angle. Oh, wait, hold on. Hold on. We can just, if we add it as a field to the rect, then everything else just works fine. We will do this. Rotation is a float. And we should specify if it's in radians or degrees. So I'll just write rotation deg here. And then in here, we can just say add attribute transform. And here we can just write rotate by some number. So what? We need to turn this into a string, I guess. Which means we have to do like const buff is equal to, you know what? I'm just gonna write 100. I know that that's way overkill, but I don't want to think. I hate thinking. You know? And here we're just gonna write rotate by some number. Rect.rotation deg, like this. Boom. And then we go const transform is equal to this. And we go transform. Form. Boom. And then here we have to write buff here. I think we're chilling. Found type, conjugate, found error, no space left, try. Cool. And so now we set our rotation is always 0. Everything should just work. And then just in our renderer, we can like set the rotation here. So let's just try setting it to ROI's TL finder dot rotation is equal to like, can we just set it to 30 and just see what happens? Can't assign to constant, so we'll copy it. So var TL ROI is equal to this. TL ROI dot rotation deg is equal to 30 degrees. And here we say TL ROI like this. All right. What's it do? Cannot add node while in attribute state. What the fuck did I fuck up? I didn't even change anything. Like, am I high? Oh, this is in draw line? Did I accidentally... Oh, I just accidentally undid too many times. Fuck. Oopsies. Oopsie daisies. It's a hard life sometimes. It's a hard life. What's that from? It's a hard knock life? Is this just a song? I don't think I've ever seen this movie. I think I've just heard it around. Which explains why I couldn't remember where it's from. It's rotating around the wrong axis or the wrong point, I feel like. Dr. Evil, does he sing in Austin Powers? Where is it even rotating around? What the fuck? Is it like rotating around the corner? No, because if it was, then the corner would stay in the same spot. I don't know, but I guess we'll just write the numbers and see if that changes anything. Rect CX and rect CY. Rotate around the center, please. Okay. I'm not gonna pretend to get it. And which way is it going? Like if I write like 15 here, is it rotating counterclockwise or clockwise or what? Clockwise. So we want to do negative of the angle that we calculate x to be at. So we want to do what we have, like our x is like going a little bit off to this side. And our existing x is this way, so we want negative this angle, which is we have its y component and its x component, so tan x is y over x. So we want a tan 2 yx, I guess. Stood math, a tan 2. The xdir dot y, xdir x, and let's take this to as a negative. Okay, let's see it. No? Why is that just not moving? SD debug print. Oh, yeah, you're good eye, good eye. Radians and degrees. Good eye, good eye. Radians are in maximum is 2 pi, so times 360, I think. Right, I think that's right. If it's not right, I'll think about it a little bit harder. Doesn't seem right. Okay, so you have 0 to 2 pi, and you're trying to get from there to 0 to 360. So you just want to go, if you have 2 pi and you want it to equal 360, you multiply by 360 over 2 pi, or pi over 180. So we do times. Oh, yeah, I just got the pi flipped. God, my math today, it's embarrassing. Everywhere it's embarrassing. And then I went the wrong way, I guess. There we go. There we go. Okay, now we also have to do some form of like adjustment of the size. That's kind of interesting, right? Because how do I say this? If you have like a square fully rotated like this, its height is oh my god, I want to copy, not save. Right? If we have this, we have like, you know, triangles. 1, 1, root 2, right? And we need our width and height to be appropriate, right? We need them to be 1 and 1 in this case, but depending on how much we've rotated, our X and Y scan lines are going to be predicting like this size and this size. So in the case of like a 45-degree rotation, we would need to divide by root 2. So it's something like we need to divide the expected width and height by something related to our angle that we just calculated. I guess it's just divide by cos theta. Because cos theta is 1 adjacent over hypotenuse. Let's just multiply by cos theta. Let's try that. So TL ROI dot width times equals stood math. Oh, we don't have a width here actually. Okay. So we have width adjustment is equal to the rotation cos this thing times the width. And we have to, this is the new width. So we say, hey, we have the old width and the new width. What are the differences between those? And then TLRI.right is subtracted by the width adjustment over 2. And the left is added by width adjustment over 2. Maybe. Could be. We don't know. Instead, that just fucking crashed, or it did nothing. What did we just do here? And can we look at, like, width adjustment as well? Oops. Let's throw a little number in here. Width adjustment was 294 pixels, based off of what was its previous width. ROI is TL finder dot width. Okay. Like, what did we just fucking do here? So we had a width of 147. We just subtracted 294. So we just do something like really, really fucking dumb here. Right, because math rotation times stood math times stood math pi divided by 180.0. Maybe that helps. I could have made a mistake somewhere else as well, but let's at least get into radians. There we go. That makes way more sense to me. Oh yeah, that's lining up good. And then we do the same thing for y, but with sine. So we have the height adjustment is the height minus sine times the height. And then we say that the bottom is minus the height adjustment over 2, and the top is added to the height adjustment over 2. And then hopefully the box hugs. I fucked up again. In what way? Let's just do the same thing here where we had ROI's height and height adjustment. How did I fuck this up? So our height is 145 and we tried to adjust by 200. How? Oh, I guess if this is negative, which it probably is, let's do a little addition there. Still not right. Okay, maybe we use our heads a little bit. So we have our rotation degrees. Of our box. I don't understand why this is any different, to be honest, but we'll get there. So we have some triangle. Boom. Right? This is what our old x direction was. This is what our new x direction was. So we have this angle and this is sine theta is this over that. And if theta is 0, we should have no height adjustment. That sounds right to me. And if theta is 90, what happens? So in this scenario, our width becomes our height and our height becomes our width. Oh, so it's almost like you need to like blend between them in some way. Right? Like, yeah, there's something complicated going on here. Where we've calculated like on our scan lines, we have this is x and this is y, but if we're in this scenario, we've calculated this is x and this is y, we need to flip them. And what if you're like at an angle? Then one of them is like way shorter than the other. So you have to, yeah, there is some sort of like, oh no, wait, because we've kind of accounted for stuff in the box. The original box x and y is this thing, and then we rotate. So if it was a 90-degree rotation, our box would be rotated by 90 degrees, in which case our x and y flip naturally. Okay. But then why am I doing adjustment at all? Because in the non-perfect 90-degree case, we do need to figure out the difference. It does seem like probably both of these are just supposed to be using cosine. I don't have like a mathematical reason for that. It just kind of feels like that's true. And it does look to be true as well. It's probably something about I'm looking at the x-axis in one case and the y-axis in another, and probably the triangles just kind of line up that they're both cosine. Yeah, that's probably it. It's probably that we're doing like a... It's probably that you have like the difference between like old x and new x is the same as the difference between like y and new y. Right, this angle and this angle are the same, and so they're both cosine adjustments for how far you need to like squish whatever you're doing. And then we have to handle something. I'm sure that this isn't right. This is probably only correct in the bounds of like 0 to 90. Because if we get to 90 degrees here, our cosine is going to be 0, and we're going to end up doing some funky math. This is going to be with adjustment of the full fucking thing. So there's something to do here where we have to like blend width and height together, question mark, question mark, question mark. Like clearly a 90-degree rotation here will result in a zero sized box. What the fuck? What the fuck? But I think this is decent progress for the day. I wish that my math was less bad, but I do think that I'm pretty happy with the ability to draw this box here. That feels damned good, right? The fact that we went from not being able to work with anything to now being able to find this same rotation will apply to these guys, and the next step would be to try to like figure out these directions, which I think is going to be fine. There's just going to be like a little bit of math to go from center of finder to like timing codes, and then once we have those, we'll probably be able to like project down to here pretty easily I say, assuming that I know how to do math, which clearly after today I'm fucking lost. But yeah, feeling pretty good. So I think we'll call it there for today. Thanks for watching, guys. If you liked what you saw, we stream most days at around 2 o'clock Pacific time for around 2 hours. So right now it's like almost 4, so anywhere between 2 hours ago and now. If you're new, there is a YouTube link and a GitHub link in the Twitch description. If you don't see the links, it's just the same username everywhere. And there we have whatever projects that we've worked on in the past. So there's stuff like operating system, Git GUI, diff tooling, like neural networks, terminal emulator, kind of just whatever the fuck I feel like is what we do. And so if you want to check that out, that's there. If you're watching on YouTube, feel free to swing by on Twitch if you want to say hi and help me figure out my math, because I'm clearly shit at it. And I think that's all we got to plug. So thanks for watching, guys, and I'll catch you on the next one.